Mischief You Gang. We're going to look at examples 3 and 4 from our notes on mini lesson number 2. So I want you to pause this video right away and look at the questions I've written out in green, those equations. Using your skills from Algebra 2, I would like you to solve all of these green equations, and then when you're ready, press play and we'll talk about them. Let's talk about each of them. So in number 3, the first, or 3A I should say, we want to use the concept of GCF to help us solve this. So to do that, we're going to factor out the common x here, which is going to leave me with y squared minus 1 in parentheses equal to 0. So in algebra, what we've learned is once we have things factored is that we can set each factor equal to 0. So therefore, x is just equal to 0. Y squared minus 1 is equal to 0. Now there's two ways of doing this. The easiest is to add 1 to both sides and then take the square root of both sides. So in this case, y would equal plus or minus 1. All right, so that's our first concept. The second concept is pretty much a linear equation. So how we would solve linear equations back in Algebra 1 is that we move all the x's to the same side. In this case, I'll subtract x to the right-hand side. We're going to then get square root of 2 equal to negative 2x. Lastly, we would divide by negative 2. My negative there kind of broke there. And we would end up with the square root of 2 over 2, negative that is, equal to x. So that would be our way in a linear world to do this problem. Now, moving to the last two, this is going to involve factoring. So the same concept essentially for these, and this is going to be quadratic trinomial factoring. And the way we do that is we're going to move everything to the left-hand side so that the equation is set equal to 0. So I'm going to subtract the 36 to the other side, and then we are going to factor the trinomial x squared minus 5x minus 36. So we need numbers that will multiply to give me negative 36, but add to give me negative 5. Those numbers in this case would be 9 and 4, making the 9 negative and making the 4 positive. Finally, we would then set each of these equal to 0. So we would have x minus 9 equal to 0, x plus 4 equals 0. Solve each of these and we're going to get x equals 9, x equals negative 4. And in our last factoring problem, so this is going to use the exact same concept. So we're going to use factoring for this. We're going to move that 1 over to the other side. So we get 2x squared minus x minus 1 equals 0. This one's a little bit harder to factor only because that first value is a 2. But when we do this, we're going to get 2x and x, 1 and 1. And I believe we got to go minus and positive. So let's see if that works because I get negative 1, positive 2. So no, I got to flip the signs the other way. So this is going to become positive, and this one right here is going to become negative. Set each of these equal to 0 and solve, and we're done. So this is going to be 2x equals negative 1. Divide by 2, we get x equals negative 1/2. And lastly, we get x equals 1. Now, why did we do this? The reason we did this is because we are now going to take some of these algebraic skills and we are going to infuse the trigonometry we've been working with into these problems. So as you look up here at these problems, at all of them, what you should notice is a common theme. For example, when I wrote tangent on these equations, I wrote x. When I wrote sines, I wrote x. Down here, when I wrote secants, I wrote x's. And lastly, when I wrote cosines, I also wrote x's. And then back on this original one, there was a second variable because we had sine here. That was my y. So notice that the equations on the left that we haven't done are trig equations. The ones on the right next to them are the Algebra 2 equivalent equations. The way you would solve these problems are exactly the same. Meaning, in this first problem, we are going to factor a tangent out, leaving me with sine squared theta minus 1 equals 0. We're going to set each of these equal to 0. So tangent of theta equals 0, sine squared of theta minus 1 equals 0, and you're going to add 1 to the other side, and then take the square root. So we're going to get that sine of theta is equal to plus or minus 1. Moving over to this problem, we would do the same exact process of subtracting sine from both sides. So we would get the square root of 2 equals negative 2 sine of theta. Divide both sides by negative 2, so we get 2 over, keep running to write a square root again there, 2 equals sine theta. Notice I'm not circling these because there is more that we need to address. Down here, we would subtract the 36. And then we would factor and set those equal to 0. Now, instead of writing x, we're going to write secant. And so that's going to be minus 9, that's going to be plus 4. And then when you set these up, you're going to essentially have one of them be secant theta equals 9. The other one is going to be secant theta equals negative 4. So there's that. And then for the very last one, we would subtract the 1, factor it. I'm just going to skip to the factoring part here. So it'd be 2 cosine theta plus 1, and then cosine theta minus 1 equals 0. We'll set each of these equal to 0. So 2 cosine theta plus 1 equals 0. I'll move this arrow way down here because this is going to be cosine theta equals, we're a little tight on space in this, so feel free if you need to write it over to the side or somewhere else, especially if you have bigger handwriting, to make sure you do that. Give yourself enough space to look at these problems. So what we now have in front of us are the trig equivalents. And at this point, these should look very similar to what we worked on here in 1a, b, and 2a and b. So now, as a final task here, I'd like you to take these equations and see if you can find the solutions to them. I will have the solutions up in just a moment. Here are my solutions. So you can take a look. In blue is the work that I actually did of solving using my calculator, and all of these answers are in degrees. So the first one's a little tricky actually because we're dealing with quadrantal angles here, but we know that tangent is going to be equal to 0 when y is equal to 0. So that's where I'm getting the 0 and the 180 from. And then sine is going to be equal to 1 at 90, and then it's negative 1. When I put that in the calculator, it gave me negative 90. And so that's actually the same as 270. So basically all the quadrantal angles for letter A. As for letter B, we went ahead, identified that we're going to have two answers, one in quadrant 3 and 4. We found the inverse to actually be 45 degrees. That's the reference angle. Notice I dropped the negative sign to use that little trick I showed in class. 225 and 315 are my answers for B. Going down to C, we have two different problems we had to do. Cosine is equal to 1/9 and cosine is negative 1/4. Using the trick of dropping the negative sign for this, I found my reference angle. Notice I wrote my quadrants down. So for this one, I got 83.6, and then the quadrant 4 answer was 276.4, and then used a similar idea. I think I want to say this was 78 something was my reference angle, and that's how I got my numbers here. And last but not least, in here, I went ahead and did the same thing, using my calculator to get the reference angle, and then applied the correct quadrants to my answer. And so the final step is the last step, and that will conclude these. There's a lot of work to these, and we are going to spend a much greater deal of time on these in the coming classes. So for now, I want you just to get really comfortable with the parts in green and red in particular, being able to look at these as Algebra 2 style equations where factoring GCFs need to be applied. So that will conclude this video, and I hope you have a good rest of your day.